Hi everybody, today's video is about ratios, and this goes with our learning goal. I can write ratios and use them to compare quantities. Okay, so we need to go over a couple definitions. We need to know what a ratio is, and the definition of a ratio is it's just a comparison of two quantities by division. So the key words there that you really want to keep in mind are quantities, and another word for quantities would be amounts. So you're comparing two amounts of things, and we're using the operation division for this comparison. And those are the two things that you really need to keep in mind when you're thinking about ratios. There are three ways to write ratios. We can write them where we're comparing two quantities using the word two, 1, 2, 3. We can use a colon, 1 to 3. Or we can write what looks like a fraction, and we'll still read that as 1 to 3. So we read all of these the same way, 1 to 3, but they look differently. So those are the three different ways to write ratios. So let's look at some different ways that we can compare quantities using ratios. So let's say we have some animals out in the field grazing, and so I want to think about what are some different ratios that I could write to talk about this situation. So what I want you to notice first is that there are 6 cows and there are 9 sheep. So one thing to keep in mind when you're writing ratios, a lot of times it's a good idea to label the numbers in our ratios. You don't always have to do that, but it's a good idea. So one thing that I could write if I was going to write a ratio about this situation would be, I could say that we have 6 cows to 9 sheep. Okay, so that looks pretty much like a fraction. It has labels in it, but it looks very similar to what a fraction would be. What makes a ratio different from a fraction is I can reverse the two numbers around and it's still a valid ratio. That's describing the same situation. We can't do that with fractions. I can't just flip a fraction over and have it be basically equal to the same thing, but with ratios you can do that. So another ratio that I could write that would be comparing the same quantities would be 9 sheep to 6 cows. So both of those ratios that I wrote there are comparing part of the animals that are in the field to the other part of the animals that are in the field. Cows and sheep are the two parts. Another way that I can write a ratio is comparing one part to the whole. So if I think about it, there are really 15 animals out grazing in that field. So I could say there are 6 cows to 15 animals. So there I'm comparing part of the animals grazing out in the field to the whole. So part to whole. So some of the first two ratios we would describe as part to part, and this ratio we would describe as part to whole. And then I could write one final ratio. I don't know if I have room for it, but I can try and squeeze it in. I could write another part to whole, but this would be 9 sheep to 15 animals. So again, I'm comparing part to whole, but just a different part. And so those would be the ratios that I could write to describe that situation. When we're talking about ratios, another thing to keep in mind is that you can write a ratio, you can write ratios that are equivalent to each other. And so when we say equivalent ratios, the official definition is two ratios that name the same number. And basically you find equivalent ratios the same way that you find equivalent fractions. So I can either multiply the top and bottom numbers by the same thing or divide the top and bottom numbers by the same thing, and that will give me an equivalent ratio either way. You can also put a ratio in simplest form the same way that you can put a fraction in simplest form by dividing the top number and the bottom number by any common factors that they have. So for example, if I go back to my cows and my sheep, I can see that 6 and 9 both share a factor of 3. If I wrote that ratio as just 6 over 9, I could divide both the top number and the bottom number by 3, and that would give me 2 to 3. And so that's an equivalent ratio, and it's also in simplest form. So if I wanted to take this ratio, if it just asked me to write an equivalent ratio, 2 to 3 would be equivalent, or if it asked me to write it in simplest form, that would also be in simplest form. I could also write an equivalent ratio of 6 to 9 by multiplying the top number and bottom number by the same thing. So I could multiply both of these by 3, for example. I'm just picking a random number. And so that would give me 18 over 27, which is also an equivalent ratio. If you want to compare ratios, there are several different ways that you can do that. You can change a ratio to a decimal, just like I can change a fraction to a decimal. So a lot of the things that I can do to ratios are the same as what I can do to fractions. You can also simplify the two ratios and then see if they simplify to the same thing, or you can cross multiply. And so I'll show you a little bit about how to do that in just a second. So an official US flag has a length to width ratio of 19 to 10. The largest US flag measures 505 feet to 255 feet. So this is asking, is this an official US flag? So we have to see, does the ratio of the length to the width, will that simplify to 19 to 10? Now, 505 to 255, those are big numbers, and I don't right off the top of my head know if either one of those is divisible by either 19 or 10. So the easiest way to perhaps compare these two ratios would be to change them both to decimals and then see if those decimals are equal. So, I don't know about you guys, but when I change a fraction to a decimal or a ratio to a decimal, I like to use a calculator. So we're going to take the top number divided by the bottom number, and that gives me 1.9 for 19 to 10. So this is equal to 1.9. And now we're going to do the same thing for the other ratio. And you can see that is not the same as 1.9. They are close, but they're not exactly the same. I could round that. If I round that to the nearest hundredth, it's about 1.98. But since an official US flag has to have exactly the ratio of 19 to 10, which simplifies to exactly, or written as a decimal is exactly 1.9, these are not the same thing. So no, that is not an official US flag. Let's look at our other two methods for this second example here. We talked about how you can simplify two ratios and see if they simplify to the same thing, or we could also cross multiply. And I think either one of those methods would work here to compare these two ratios. So if I have two ratios and I write them as fractions right next to each other, one thing that I can do to compare two ratios is to multiply the diagonals, the numbers that are diagonal from each other. So I could multiply those two numbers together, and I could multiply those two numbers together. It turns out that with fractions and with ratios, if you multiply diagonally like that and you get the same number, then those two things are equivalent to each other. So if I multiply 50 times 7, I'm going to get 350. And if I multiply 10 times 35, I'm also going to get 350. Those are equal, so that means that these two ratios are equal. So that's one way of comparing two ratios, and it's especially an easy way if the numbers involved are ones that you can multiply in your head. Another way of checking whether or not two ratios are equal is to simplify both of them. Now 7 to 10 is already simplified because there aren't any factors that 7 and 10 share other than 1. 35 to 50 can be simplified by dividing both of these numbers by 5. And so when I do that, I would get 7 to 10. And so those two are obviously equivalent because they simplify to the same thing. The answer to the free response question is going to be snow day. So when you come to the free response question in the video, you can ignore the actual question, and then in the form, just type the words snow day as your answer to the free response question. And here are your free response and multiple choice questions. Go ahead and pause the video now and answer those. And when you're done, have a great day. Thanks.